The reason this skill is important isn't necessarily because of chemistry, but it's because it's difficult. Um, we're gonna we're gonna start a really long process where you have to gather information from multiple places to solve complex problems. And you may not ever do that in chemistry again, but you'll do that your entire life, where you have to gain information and solve problems based on that information. All right. So for some of you, a lot of you actually, what we're doing right now, you may or may not remember it, but the process, the exercise, the skills that you learn will be really important and really helpful. So let's go ahead and dive in. First off, there was 3 questions at the bottom of the lab yesterday. Did I thumbs up if I went over those in that video? The 3 questions at the bottom of page 2. No, I did not. Okay, so let's make sure that we have those real quick. So the conclusion questions at the bottom of page 2 say, what evidence of chemical reactions did you observe? Will you turn to your partner and tell them at least one evidence of a reaction that you saw? Hey, Karen, I can wait if you want to call roll.
Oh, are you sure?
Yeah, sorry. I didn't even think about that. Go ahead.
All righty. Kobe.
Here.
Kira. Here. Amber. Blake.
Okay. So I heard Jared tell his lab partner or the whole group that color change was one of the evidences of a reaction that you saw yesterday. So that is definitely one. Another one you should have seen yesterday. So hold on. You should have seen a gas given off. So raise your hand if you saw bubbles. All right, everyone raising their hand is paying attention. Thank you, Colby, for being awake. That's nice. All right, so color change, and then you may or may not observe this, but there's actually heat given off as well. You don't have to write that. When you put 3 of those metals into the acid, they give off heat. So those were a couple. And then number 2, the difference between a clear and a colorless solution. Kids get stuck on this one every year. Clear just simply means it has nothing in it. All right, you can see right through it, but it can have color. So in the lab, we had that beaker of copper 2 sulfate. And copper 2 sulfate is clear, but it's not colorless because it was blue. But clear means you can see through it. There's no chunks or anything like that, but it can have color. Colorless simply means the absence of color. So that would be like a beaker of water. It would be clear and colorless. So that's just that. And then finally, the one that's the most important is to define a precipitate. So a precipitate is when, I'll write it out here, when 2 liquids react to form a solid. All right, so when you did the lab, you should have seen that CuSO4 plus potassium iodide made something brown. If you look at your data up above, that should have been kind of a darkish brown looking substance. That brown substance is Cu(I2), or what's known as copper 2 iodide. And then the rest was just left over, K2SO4, doing nothing. This thing right here is the precipitate. And oftentimes in a reaction, when you see a precipitate, you'll have a little parentheses and an S right here, and that means it's solid. These 2 things here were aqueous, so you'll see an AQ, and aqueous, you'll see an AQ right there as well. And then solid, and then AQ. Now we'll talk about these things here in just a minute. So make sure it's a matching term. So make sure that you know a precipitate is when two liquids react to form a solid. Now, the whole thing didn't just turn to a solid chunk. It just made some solid that goes to the bottom or falls out. And that's where it gets its name precipitate, which is like precipitation, like rain that falls down. The precipitate settles over time. All right, so hopefully that wraps that lab up. And then let's just dive into page number 3. Please make sure you're paying attention today, and hopefully the videos from Monday helped as well. And we'll just get after it. So the first thing, make sure you know right here that these are some matching terms. All right. So not all of them are matching terms, but some of them are. So this first one and this arrow means yields or goes to. So when we have a chemical reaction, we're going to put things together, and then the arrow means they go to or create new substances. The plus sign, it separates products or reactants. Then a little g, that means the substance is a gas. AQ, it means it's dissolved in water. Liquid means it's in the liquid state. And solid means it's in the solid state, or S, I should say. Now, sometimes kids get confused on what aqueous and liquid mean and the difference between them. So the difference between them, if I put NaCl and put an AQ, that means that this is salt dissolved in water. If I put NaCl with a liquid, that means I've heated this up to 3,000 degrees and we have molten salt. So they're super, super different. And really, we don't deal much with liquids unless it's like water. Most of the time we deal with aqueous. So make sure you're comfortable with these words. And so when I use some of these terms, you're ready to go. All right. Then we have these two blanks right here. These are really important because I'll use them the rest of the year. So when we have a reaction, we start with our reactants. All right, so please, these are super important words. We're going to use them so much. You don't necessarily have to memorize them, but you 100% need to know what they mean. So reactants are the things that we start with. And then we put our arrow, which remember means yields or goes to. So reactants go to the new substances are called products. All right, both of these terms will be used over and over and over. The reactants are always what we start with, and they're always on the left. The products are always what we go to, and they're always on the right side. Oops, I guess I should finish that. Okay, so a simple example from the lab you did yesterday. We would have taken magnesium solid. That was one of my reactants. We put it in hydrochloric acid, which is aqueous. It produced or yields hydrogen gas. Whoops, I did that a little wrong because I needed 2. Hydrogen's diatomic. That's why it's going to get a 2. Plus the other things that were left over were MgCl2. And this would have been aqueous. All right, then today, our goal then would be to balance this reaction because I can't have more H's and Cl's on the right than I do on the left. So we'll learn that we'll just put a 2 in front of the HCl and that balances everything out. Okay. So we'll dive in now to the balancing act. And once again, hopefully the videos helped a lot. So just kind of follow with me. You may not enjoy like drawing it out, but it does help quite a few people learn it a little bit better. So let's do this. Good morning, Kennedy. Thanks for turning that in. All right. So in the balancing act, our entire goal is to make sure that this arrow is really an equal sign. I need the same number of every type of atom on each side. So before I get into this, and you don't need to draw this out, and I don't remember what the video was yesterday, well, what I covered in it, but if I've gone over this before, I apologize. So if I wanted to make a bicycle, my bicycle would be my product. And my bicycle would consist of a frame, and then it would have 2 wheels. And I would put the formula like that because the bicycle's all together. It's not broken into its parts. All right. And so on the left, my reactants, I would need a frame, and then I add wheels. Now, the wheels are not connected to each other before, so they're alone. So in order to make this bicycle, I need 2 wheels and 1 frame to produce 1 bicycle. All right, I need 2 here because it's a 2-to-1 ratio in my formula. Okay, all we're going to do now is the same idea, but with words that might sound confusing, like aluminum, copper 2 sulfate, aluminum sulfate, and copper. All right, but we can do the same process. We just make sure that I have the same number of ALs on both sides, the same number of coppers, and the same numbers of SO4s. All right, so this is how we would balance this. And we'll do a lot of these today. But my advice to you is to always find the biggest number that's a subscript that's not part of a polyatomic ion. So it's actually this 3 that I want to start with. I would not choose the 4 because the 4 is part of a polyatomic ion. And if we look, don't break SO4 into pieces if it's together on both sides. That would just give you more work to do. Balance SO4 as one single thing. All right, so on the right, I have 3 SO4s. In order to balance that, I need to take this 3 and put it in front of the compound that has SO4. Now, this process is all about fixing a problem and then fixing the problem you just made. So as a homeowner for now, I don't know, 17 years, every time I've tried to do a plumbing project, I end up fixing more after I break what I tried to fix in the first place. When we balance, we'll fix something and then fix what it broke. So follow me here. The 3 SO4s took care of this piece. But when I put it over here, it made 3 coppers. So in order to fix that, I have to put a 3 in front of the Cu. Okay, so to fix the sulfates, I needed 2 different things. I needed a 3 in front of copper sulfate and then a 3 in front of copper. Now I'm not done yet. There's 2 aluminums on the right, so I have to put a 2 right here, and then I will put a 1 right here. So this reaction, when it is balanced out, is 2, 3, 1, 3. Now, we're going to draw this out to try and help you understand what this actual process is doing. So down here, I have 2 independent aluminum atoms. So I draw them separate. Now, please look at the screen for just a second, if you would. Numbers that we have down here are called subscripts. Subscripts tie things together. Numbers out in front do not tie things together. They tell me how many there are, but not how they're arranged. They're just completely separate. Okay, so follow me back here. I had my 2 separate aluminums plus 3 copper 2 sulfates. Now this is all tied together. So I'm going to put a Cu, and then I'm going to put an S, and then I'm going to put 4 O's around it. And then I would draw this thing 3 separate times. Now I'm going to cheat, but you go ahead and, oh, that's so small. Oh my heavens. Go ahead and draw that 2 more times. All right. So make sure you can see the structure of this as we go through. 2 separate aluminums, 1, 2, and 3 separate CuSO4s, but each one of those is together. All right, then my arrow, and then I got a complicated drawing, but at least it's only one of them. So I'm going to draw 1 Al2SO4 3. All right, so when we draw a 2 to 3, you may remember from last year, I guess, whatever, before the break, we always put the thing that we have 2 of on top and bottom. And then we put the thing we have 3 of sandwiched sort of in the middle. And that would be the SO4s. So I'm going to go ahead and draw 3 S's. And then each one of those, I'm going to put 4 O's around. Kind of getting ugly, but you sort of get the idea. Ashton, do you have a new lab book? We're on page 3. It's right there to your left. All right. So now we only drew this structure once because we only have one of them. But we have 3 separate CUs now. So CU, CU, CU. And those aren't very pretty U's, but whatever. So now hopefully you can see the structure drawn out here. And then hopefully you can also see the balance. If you'll look on both sides, you'll see 2 red aluminums. So 1, 2, I'll circle them, 1, 2 on the right. If you look on the left, you'll see 3 of the black coppers. And on the right, you'll see 3 of the coppers. Okay, and then I could do the O's and the S's, but I'm just going to do them together. So you'll see that I have 3 SO4s, 1, 2, 3, and 3 SO4s. So I could turn this arrow into an equal sign. The amount of matter on both sides of the arrow is exactly the same. And that's what we do when we balance chemical reactions. We make sure we have equal amounts of matter on both sides of the arrow. Okay. Thumbs up. Uh-oh, Arrington's asleep again. Oh, never mind. Sorry. So this idea, and we don't draw them out all that much. We will in an activity we do when I get there tomorrow. But when you draw them out and see the actual structure of the balance, it usually helps quite a bit. Okay, just some quick rules on the bottom for balancing equations. All right, so we're not going to really reference these that much, so I'm going to fly through these, right? The chemical equations, either word or formula to represent the facts. Now, at first, they're just given to you, but pretty soon you're going to have to take the formulas from the actual words, and then it gets complicated. All right, determine the correct formulas for all the reactants and products. If you have this wrong, ooh, you're in trouble, okay? And then write the formula for the reactants on the left and the formula for the products on the right with an arrow in between. If you have two or more, you put plus signs. And then number 4 starts with balance the elements one at a time by using coefficients. You can't read my writing. That word is also right there typed out. All right. Now, a coefficient, there's the definition right there, is a small whole number that appears in front of a formula in an equation. We absolutely, please, you need to have this knowledge. So just a second ago, we had 3, and then we had CuSO4. This is the coefficient. This is a subscript. When we balance, we change this number and never that number. Okay, I didn't just say I needed Cu3 SO4 3. That's not how it worked. I needed 3 CuSO4s. Okay, so make sure that you're solid there. Okay, the rest of the hour, we're actually going to work through your homework problems for practice. So turn, I think, probably to page 12, but let me double check. Yes, page 12. All right, page 12. And if you are good with these, you don't have to really pay attention, but 99% of you should pay attention and have me help you get through these. So what we're going to do are problems 1 through 10. But while we do problems 1 through 10, I'm going to talk about what I call these balancing reaction helps, or I call them Tom Davidson's time-saving tips to save you time tips. Now, I know that's an amazing name. I wish I could be there to see all your smiles when I say such a wonderful name. But these are helpful tips, but they're not required. If you can do it other ways, that's fantastic. But these are just things that have helped kids over time. So just quickly, when we start to balance, we usually choose the highest subscript, not part of a polyatomic ion. All right, now I had a misprint. Oh, never mind, I have it here on paper too. So it is correct still. Then we'll see problems where you write water as HOH instead of H2O. That will save you a ton of time if OH is on the other side. Number 3, we already sort of applied this. Keep the polyatomic ion together if they are on both sides of the arrow. So for instance, we had CuSO4 on one side and Al2SO4 3 on the other side. There was no reason to balance O and S separately when we could just balance SO4 together. Then this one sounds like I'm a third grader, but I don't care. If you see a 3 and 2, you should use the swapperoo, and I will teach you what that means. It's really easy and helpful. Number 5, when there's lots of things, you know, I don't like how I say this anymore, but whatever. If there's lots of things, choose to start with something besides oxygen or hydrogen. This would probably be easier stated. Choose to start with the metal. All right. Usually when they're complicated and there's lots of H's and O's, there's a metal. And if you start with the metal, your life is much easier. Okay. Now, there are more, but we won't get into those until we do a lower problem. So here's what we do. Number 1, we have Al2O3 goes to Al plus O2. Will you take a minute and try and balance that by yourselves, and then we'll go over it together. All right, I can't see very many of you. Raise your hands if you think you have an answer. 1, 2, 3, 4, 5, 6 of the 1, 2, 3, 4, 5, 6, 7, 8. I can see. I'll call that a success. All right, now I will work through it while I talk about these tips. So first off, start with the highest subscript not part of a polyatomic ion. I will do that. I have a 2, I have a 3, I have a nothing, and I have a 2. So I'm going to start with this 3 because it is my highest number. All right. Now I have a 3 on this oxygen and a 2 on this oxygen. Well, conveniently, I have this idea number 4. If you see a 3 and 2, you should use the swapperoo. What that means is this 3 goes in front of this 2, and this 2 goes in front of that 3. Now, like plumbing, I solved the problem, but I also made one. If I have 2 Al2s, I really have 4 aluminums. So over here, I have to put a 4. So the correct answer would be 2, 4, 3. Did anyone have that right? Raise your hands if you did. All right, 1, 2, 3, 4, 5, 6 of the 8 I can see. So that's progress. All right. So that is an example of one that's fairly simple. Let's dive in and do another one. Number 2. This one's not bad. Will you take, I don't know, 30 seconds and try and solve this one first? When you have this one balanced, and by the way, for right now, don't worry about the type of reaction. I'll teach you that when I get back. So just leave that blank for now. So when you have number 2 balanced, will you check with your lab partner and see if you match? Jared, show me in your fingers what your 4 numbers are. I believe if I watch your sign language right, you have it correct.
Yeah, I'm not surprised. Massive.
Okay, I'm glad you're not surprised. Yeah,
You should do number 4.
I will do number 4. Is that Ethan that's talking? So Ethan? Uh-oh. My computer is not responding. That's not a good sign. Number 4 follows the rules higher on the page that says combustion tips. That might help you. I'm in trouble if this is not going to work. Oh boy. If my computer crashes, give me a few minutes and then log back in. But hopefully it won't. Okay, looking at number 2. Let's see, I make this go away. Oh my heavens. All right. Can you guys still hear me?
Yeah.
All right. Smart notebook, which I use for everything, is not responding. So you should have 1 magnesium and then 2 HNO3s, then 1 MgNO3 and 1 H2. So raise your hand if you had 1, 2, 1, 1. Okay. Try the third one while I try and reset Smart Notebook.